AB Calculus Note Card 76, Slope Fields. This is the 76th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas School District, who developed this note card system. Slope fields or direction fields are graphical representations of differential equations, a visualization of the parallel curves that solve the differential equation without algebra. And these are used when you cannot solve the differential equation. Specifically, when we solve a differential equation, we get first what's called a general solution. And then if we are given a boundary condition, like a specific point, let's say we get a point that's on the curve of 0, 1, we can substitute it, use to create a particular solution. And what happens is, if we are in a situation where we do not have, let's say we do not have this thing here, we are unable to go from a general solution to a particular solution. So what a slope field is, it's a graphical representation of the general solution of a function. Sketch the slope field for dy dx equals 2x using the table below. And first I'm going to demonstrate like we've done earlier. We find a general solution. If we put dy dx and we set that equal to 2x, if we cross multiply the dx, we get dy is equal to 2x. Let me put, I'm thinking ahead of myself. It's equal to 2x dx. And if we take the integral of both sides of this equation, we get y is equal to 2x squared over 2 plus c, which simplifies to y equals x squared plus c. Now, we are not given a specific point, and so we cannot say what the actual function is. So this is a general solution. So we're going to use slope fields to see what the curves could like, the family of curves. So what we're going to do is look at all these points and draw in little slashes that would represent a slope at that point. So if we go ahead and see what those are, we would put little slashes like this. So let's go take a look at filling out the chart. So we have this, we have a table we can use, and if we put an x value, we start over to the left, say, and let's say we want to focus in on this particular point here at x equals -2, y equals 2. So we put -2, 2, and to find dy dx, what we do is we put 2 times x. So it's going to be 2 times -2 is equal to -4. So what this means is that our slope at this particular point, our rate of change is going to be -4. So we can represent that by drawing a steep negative slope line segment, and it's going to have to be just approximate. Next, if we try, we want to try another -2 value. Say we want to take -2, x equals -2, y equals 0. But we still have 2 times -2 anyway. So we're going to get -4. So right here, we're going to get -4 also. So we draw on a very steep slope line segment like that, -4. And we should be able to quickly see that no matter which point we put in where x equals -2, we're still going to get -4 as an output. So we can put right here in all this vertical column a slope approximation of -4, something like this. So very, very steep downward slope. Next, we want to go to -1. If we put x equals -1, and let's say we want to put in -1, I don't know, -1, yeah, we'll say -1. So we're going to look at this slope right here, -1 comma -1. What we're going to get is 2x. So we're going to get 2 times -1, which equals -2. So we're going to put a slope of -2, which will be a negative slope, but not as steep as the original one, and that's going to be the case as in this one of -4. So a slightly less steep slope line segment here for each of these points. Now, the AP tests are not going to look very critically at what those are going to be. Next, we have an x value of 0. Well, then let's say we'll use 0, 0. So we're going to get 2 times 0 equals 0. So here we're going to have horizontal line segments. Next, if we choose 1, x value of 1, let's say we want to pick 1, I'll go down here, 1 comma -2. Well, it's going to be 2 times 1 equals 2. So we're going to have an upward slope here like this, and likewise for every point above, we have a slope of 2. And the last thing we're going to have is this final column. Let's say we want to put 2 comma 3. So this point right up here. Okay, to do that, we're going to get 2 times 2 is equal to 4. So we get this steep slope line like this. There's little line segments here. And what happens is these slope fields will go ahead and form what the general shape of that parabola will look like. It looks something like this. Okay, what I just drew in the dotted line. But you can see that with this C, if we take this thing, it could be moved up and down and fill in here roughly. And if you are asked to draw in, as I just did, a curve, and I know that may not be particularly accurate looking, but that'll be good enough as long as you're following the general shape of what these the slopes at these points of the slope field. So really that's it. Most of the time you see these problems, you're going to see a function in terms of x and y. Okay. Most you'll see it in terms of x and y. So if you have x and y changing here, you're going to have a more irregular pattern and not as easy to draw as what I just did here. Not a very hard concept or thing to do. I hope this has been helpful to you. Good luck, and thanks for viewing.